I think I'll just kind of just give a short overview of what we did last week. Were you there last week? No. Okay. So it was online, and we tried to look at the different networks, the deep learning networks, and we saw their functionalities and their characteristics to help us to be able to understand how they can be designed, how they can be structured, and how they can be used, and where they can be used. And so that was what we did last week. As the slides are made available to you, please just go through the slides, do your in-depth study, and you can always send questions to us, and then we'll be able to help you through. But today we just have to proceed. And so for this particular week, we are going to be looking at model evaluation and optimization. Model evaluation and optimization. Please, you can come closer. I won't need to shout because there are just three. So let's have a conversation. No, you're okay. You're okay. Please, you can just come. Are you good there? You can hear me well? Okay, fine. And for those of us online, I hope you can hear me. You're welcome. I hope those of you online can hear me. We are going to be dealing with model evaluation and optimization. We've talked so much on, yes.
To check that you're sharing your screen. I think the message just popped up, but I'm not sharing.
Mr. Ode, he said a message just popped up. Oh.
This is how it's showing.
Are you seeing it now?
Yes, you can.
The screen is not showing you instead. It's not there.
No, it's not sharing the. But are they hearing? Can you hear me?
Yes.
Okay. Okay. Please.
It's something. It's not showing the screen. Can you see it? The screen completely. I don't know.
Or should we just close it down and
Restart
set
it.
it up again? Or should we just close it down and set it up? Let's present. Or should we just close it down and set it up? Let's present.
Select the file you want to present. Is there the Windows?
Okay, you know what? Upload the file again from the flash onto your system, and then we'll start over. So please just hang on a bit. Let's make sure we are doing it right. So please just hang on a bit. Let's make sure we are doing it right. Please put up.
Is it this one?
Yeah, that's week 4. I'm not seeing week 3. Okay, just put it.
No. Because
Okay, it's on
yeah,
there.
it's on the other time.
It's all right.
Can cancel and do it again.
Because the share is not activated.
Present now. Let's try it. On your computer. Okay, upload. Okay.
It's loading.
Is it loading?
It's loading.
It's loading.
Okay.
Okay.
It's on. It's on.
We didn't have a problem last week.
Okay. Let's try a different method. Is that share screen? Folder was open. This one.
It's open.
Okay. It's interesting. It should be showing.
It's not showing.
No, not yet. I said it's
But it's
showing.
sharing.
Yes.
It's sharing.
It's not showing.
Let me go out and come back.
Those of us online, can we see it now? Those of us online, can we see it now?
It's not.
Yes, they are replying no.
Nobody's responding, but.
Or you can.
Yeah.
Yes, they are replying
Someone just responded. I said no.
no. Okay.
Just one more.
Okay, stop sharing it now and then restart it.
No, that's okay. Stop sharing.
Stop sharing.
Let's stop sharing and share again. And then maybe present. Share screen. Let's click on share screen there. Okay. Let's check this.
Still the same.
Still the
Just
same.
wait a little. Sometimes
Maybe we'll just
it can-
hang on a bit. Today's class is not doing like before. Maybe because it's the last on deep learning. Otherwise, the system is saying no, I won't do. No.
I said we can see, but not this slide.
They are not seeing the slide at all.
coming up.
It's coming
Yeah,
up,
it's
right?
like seeing screen.
Are you seeing it like this?
Yes.
Yes, go inside. Yes.
To the side.
Okay, that's yes. Yeah.
Side is sharing, but it needs to be made to main to we can yourself rather than
Mr. Harriet or Manatu, we have
yeah.
Yeah.
All right. Sorry? It's, it's not a matter of learning. We didn't see you. We didn't see Miss Hanatu.
She's supposed to send the link and then monitor the
No, we did. She sent the link, all right, but okay. All right. Sorry about that little hitch. We needed to get permission. Model evaluation and optimization. That's what we're going to be doing today. And okay. I'm happy we can all see the slides now. And so we'll just go step by step. We probably will be a little bit fast because we have little time, and I really, really want us to do a little bit of hands-on by the end of this class. So we're going to, when we are discussing model evaluation and optimization, we have entered the stage where we have trained, we are looking at the training model. We looked already last week at the different kinds of networks that we will be working with as we go along in deep learning. But now, how can we talk about model evaluation and optimization without knowing what our parameters are? And so that's why we are starting with our hyperparameters. We're starting by understanding our hyperparameters. Okay, for this, if you have to run, the way we explain it, you have to run any process. For example, you need some parameters that you would use to run that process. Let us take it from here. There are adjustable parameters in deep learning models that are set before the training, right? And then they actually determine how that model will perform, the performance level of the particular model. And so, looking at that, let us take our analogy from Mr. Ode. I want to put this on full screen, and I'm having issues with this.
Full screen.
The full screen. We are not moving.
It's okay now.
Okay, that's fine. All right. Okay. Thank you. I'm sorry, let me just come back to myself after the whole. I want to let us understand what we mean by our hyperparameters. Let me take our analogy from fire. Fire, for example. If you want to light a fire, what are the factors that need to come into play for fire to come on? There must be what? Fuel.
Yes.
Air, which is oxygen,
Yes.
and that's heat, some form of heat. These are the triangle. You have the heat, you have oxygen, which is air, and then what? Fuel. And then fire comes on. These different factors that will make for fire to come on can be likened to our hyperparameters in deep learning. And there are several of them. And now, the way you tweak your heat or the oxygen, the wind, so to say, or the fuel, will determine how big the fire will be, right?
Yes.
The way you tweak your parameters will determine how the performance of your model will be. Am I communicating? And so that's why we're looking at hyperparameters in this sense. We have to look at it one after the other. The whole essence of model evaluation and optimization is to arrive at a point where your model is operating at optimal level. Do we understand? Okay. Now, let us look at our different key parameters. Our key parameters, we have the learning rate, and it determines how quickly the model learns. You must look at the learning rate in the training data. And then we have to be careful about our learning rate. There's a way to control it though, but for your learning rate, you want to make sure you don't get into a position of overfitting. Do we understand? We have dealt with all that about overfitting, underfitting, and all that. So we look at learning rate, which is number one. Secondly, we are going to be looking at our batch size. By the way, for our learning rates, if you notice, if we are programming it, we know that the learning rate, you can see that the decimal values are there from 0.1 to 0.001 is a float value. That's we are looking at our variable. If we are in a programming environment, we're trying to program it. Now, for the batch size, the standard is between 32 to 512. Don't concern yourself too much about that. But because when we enter the next module, we'll bring this into play. But you should know that they are integers. And the batch size determines the number of samples that are processed together as a single unit. So we are looking at the batch as a single unit when we are processing. It is one of our key parameter, a hyperparameter that we need to consider when we are looking at model evaluation and model optimization. Next, we have our hidden layers, the number of hidden layers you have. Remember what we discussed about our layers, and we talked about our hidden layers. The number of hidden layers you have will also determine the complexity of the model. And what does that tell us? The number of hidden layers will show how well your model can solve complex issues. Do you understand? And so next, we have the number of units in the hidden layers. How many of us remember those nodes that we were talking about earlier? So the number of units, this is another key parameter. And I hope we know that so far, what we are trying to do is to tune our parameter. It's called parameter tuning. If you were in the last class, you know that one of the ways that will help you in preparing your data is, we talked about cleaning, and we also talked about parameter tuning. And what do we mean by tuning? You know the way you tune your radio system or whatever to be able to get the right frequency. That's what we are doing here. We're just tuning our parameter, but we're trying to understand what our hyperparameters are. And then the next is, of course, is your activation function. Remember what we talked about our activation function. We have different types of activation functions, and then we are saying that they are all listed there. And what is the essence of these different types of activation function? Because you use different activation functions for different classifications. And remember, we talked about our binary classification, our non-binary classification, and the in-between. It could be binary, it could be non-binary. And then you have the different activation functions to use on that. And of course, our activation function is the variable type of our activation function is what? A string. And then the optimizer. We have our optimizer. This determines how the model's weights are updated during the training. Do we remember our weight and our biases? Yeah. So we are just going on. We now understand. Now, this particular hyperparameter and the next one, they help us to control our overfitting. They help us to control our overfitting. It says it determines the penalty term added to the loss function to prevent overfitting. And then we have the L1 and the L2 regularization techniques. And of course, they are float. And then the dropout rate. This is another. You see, when you are having a situation of overfitting, you introduce regularization and then the dropout rate. What does the dropout rate do? It determines the proportion of neurons that are randomly dropped out during the training. What do we mean by that? Relate it to overfitting.
Okay, when we talk about overfitting, now, you said it is when we have too much data being fed.
Training
Training a model.
data
Yeah.
in the model.
Yeah. So
And so it can be overloaded.
okay.
And now you will see that load, there are so many data in there that will not be necessary, that you can do without. Now, this dropout rate allows you to drop some of those data. And then the rate at which you do that is what we can explain as our dropout rate. Do we understand? Sorry? So, please, I didn't hear the second. Yeah.
And then when the listen is being overloaded, you see that all those data, all like there are some insights that are not needed or that they are not essential.
We call them outliers. What do we mean by outliers? These are the ones that you can do without. But even if they are there, they can function and then cause overfitting. But then you can abstract them. This dropout rate can help you do that, and regularization. Do you get it? And so, okay, we probably will have a summary of all this and then marry everything together. And the approach is determines how many times the model sees the training data. Increasing the number of these can improve the model's performance. Everything we have been saying is about improving the model performance. That is what we are actually focusing on. And then if you look at the next major point now, we now go into our evaluation proper. What is the essence of this evaluation? The diagram puts it in a nutshell. It's almost like a feasibility study. Now, when you do a feasibility study for any project, what is the end game of the feasibility study? You want to know whether it is necessary to go along with that particular project or to drop the project, and then recalibrate and find another project or tweak the structure of the project to go a different direction. So that's the whole essence of our evaluating our model. to see whether it is a good one or a bad one. How can we adjust it? Do we go back to our hyperparameters and begin to tune all of them to see that we are going in the right direction? That's why we have that definition there. It said model evaluation is a crucial step in deep learning that involves assessing the performance of a training model on a given task. Okay, now how do we go about our evaluation? Next, we have here that we have key aspects of model evaluation. And what are those key aspects? It's like it's like the generic structure of evaluating a process. And so looking at these key aspects, it says yes that the evaluation metrics provides a quantitative measure of a model's performance: accuracy, precision, recall, F1 score, the mean error, and then the absolute error, mean absolute error. And I want to zero in on the F1 score because we are looking at our predictions from our model. What does our AI model do? Basically, they predict. If you give it a task to do, it predicts an expectation from you. You have an expectation that it should do this. And then the model predicts for you. And then using your F1 score, it actually predicts. It actually measures the prediction performance of the AI. They are actually mathematical functions, which, to be more specific, they are statistical functions. So those functions, I want you to be very particular about them because when we enter the next module, we are going to be looking more into our F1 score. So you all know accuracy. You all know precision. And of course, recall. When we are talking about our recall, we are taking our mind back to the feedback. Remember the feedback? So let's continue. Okay. And then next, we have our cross-validation. Cross-validation is a technique used to evaluate models' performance on unseen data. Splitting, dividing data into k subsets. Next, overfitting and underfitting. Do we have to discuss this? But it is something that you should put into, consideration when you are evaluating. Underfitting occurs when a model is too simple and fails in the underlying patterns of the data. All right, of course, we have discussed a lot about our overfitting, but underfitting is when you don't have sufficient training data to inform your model. Do you get it? So next, let's look at our hyperparameter tuning proper. There are techniques that we use, and I will just mention the techniques, but we are going to explore these techniques in depth in our next module. Now, the first one is our grid search. We have our random search, and then we have our parameter optimization. Next, let's look at our model selection. That's number 5. Remember, we are looking at our techniques for what? Good. All right. Model selection involves choosing the best model from a set of candidate models. And then we have the handout method, evaluating models on a HELDA text set. And then we have the k-fold cross-validation, which means we are evaluating our models using a k-fold validation. All right. Let's quickly Am I too fast? Am I too fast? We have, am I okay?
Yes.
All right. Model selection. We have a set of candidate models, that is, models that are presented for the evaluation. And then for this selection, we need to go through that process of selecting the right model. Remember, we need to also select the type of network we will use for the evaluation of this model, or to be able to work with these different models. And you know we have different types, and they are not all to be used for every of our functions. No. What are our networks? There are three major types that I'm going to bring out when we get to the application stage. We are going to be looking at our CNN. What is our CNN? Convolution neural network. We are going to be looking at our RNN, recurrent, and then we are going to be looking at our GAN. Adversarial network. Thank you. Am I okay? All right. So let's proceed. Next, we are going to be looking at our model interpretability, understanding how the model makes predictions, and next we'll come to the next big one, which is our model optimization. Remember what we said. We said that our topic for today is what? Model what? Evaluation and optimization. And now, if you look at that diagram carefully, we have here that hyperparameter optimization can only be achieved with the best hyperparameters. And we have just gone through our different hyperparameters that we might be needing. And then the model training, the best model parameters. And so here we have that our model optimization, being a crucial step in deep learning, involves improving the performance of the efficiency of the trained models. Are we okay? The slides are not cooperating with me today. Okay. Pruning. What does our pruning remind us of from last week? It's similar, but it's not exact. What does it remind us of? The cleaning of the data. But in this case, it's removing of redundant or unnecessary weights and connections in a neural network. It reduces the model size. And one of the major benefits that it promotes speed. Speed in the process, it reduces the computation time. And what do you get? Efficiency, a more efficient model. Next, we are looking at our quantization. Okay, reducing the precision of model weights and activations from floating point numbers to integers. There's a rounding up going on there, right? We are rounding up our decimal points to whole numbers, which is our integers. For those of us, you understand what we mean. So making, and you know what that means. The computation time is reduced, and you now have efficiency, speed again. So next, knowledge distillation. You have training a smaller student model to mimic the behavior of the larger teacher model. So it's like you are using, you're having something like a prototype to simulate the actual. So whatever error you make there, you can easily correct and work on before you get to doing the real thing eventually. And so next, we have the compression of our model, reducing the size of the model while preserving its performance. That's another optimization technique that we are going to be using. Sorry, we'll just span through. I want us to do the practical exercise before this class ends. Okay, efficient neural network architectures. When the slides are given to you, you can just quickly go through them. We have the neural architecture search, and we'll go straight into our applications. Now, I told you we are going to look at the three major types of neural networks and see how they are applied in real life. I don't know if we can quickly, for those of us that are at home and we are online, I want us to explore this site. Explore the site and see what this particular AI will do. This is exactly what my aim. This is where I've been rushing to. So those of you that are here, if you can get to it. You can snap it. You can take a snapshot of it and then try and open. Let's all open the first one. I want us to do this here. Those of you that can see the first one. Okay, you can snap it.
Yeah, but on the second one. Yeah, 2 seconds.
Yeah, three.
3.
Just take a snapshot of it. Okay. All right. Are we there? Have we opened it? Take your time, open it up. Yes, go ahead. Use the browser for it. It's mobile friendly, so. Stephen, you can join somebody else. You can join somebody and then see how that works. Is it loading?
This side.
Yes. Can you see? Good. Can you see the first one and look at the second one? What did we say about our generative adversarial network? It's a combination of two different lines to give us what? One, it now gives us a new artificial one network that's different. And we apply that network architecture to an AI like this. Now, what you're going to do, you're going to add the two. And then, if you see, you're going to connect both of them together. Let me show you something. Both of them, you see, you are going to connect it. What are you connecting? The two pictures together. Look at the two pictures. You can choose. There are other ones that are there. Did you see them? Did you see the result? Can you share the result? You should just look around and look at the results. Take your time. Those of you, look at. I want you to see. Did you see? That is not the only photo that is there. Those of us online, please try to open this site. And then you see that it is generating something new, but it's artificial. It's not the exact, it's not the original. And we are using our adversarial network for that, the generative adversarial network. That is what I want us to see. Now, there's something you're going to, have you done it? Yes. Did you see that? Yes. You see what it generated for you? Yes. That's not sufficient. Now, if you look at the original photos that you just played around with, there are more photos there. Begin to choose different photos and connect them to give you something new. Are you getting it? You can join somebody else. Those of us at home, are we getting it? Please join up. I don't want to see you let you see how powerful this is. Then change your parameters. Tune your parameters. If what you're getting is not, then choose it. You're combining both. What I'm trying to do is, they are using that networks.
No, let's start with the cross. Click on the cross. See your level of stress. You see many pictures.
You see many pictures, click on it. And begin to combine. Mr. Ode, please excuse me. I want to try and remove myself from there so that they can see more of this. I'm trying to do that and then it's not this. I want only this to show. I don't want any of this to show. Yeah. So that they can see all this. I have to bring my tablet. Because when I did it online, the control from this Hayat to Wanato. If we click on this, they can hide it.
Anyone you click.
You see? Combine. So, what is this? Well, okay, you can sit. Please. You can sit with me so we can go to the other side and see what we can do. Now, this is what we can do. No, just leave it like that. The administrator will be the one to.
Okay.
Did you go back to the? Let's go back to the slide. So.
Wait a second.
I want to take. Yes, and it's from the.
Yes.
Top. No problem. Those of you here that have it at home, they'll be able to. Okay, we'll copy the. You copy the link and send it. Yes, put it on the. Please, can you copy the link or tell Hannah to copy the link and then send it to those online so that we can log in it. Now, this is what I want us to do. Hello? Are we seeing something there? These are two different AIs. You are combining them. But what kind of network? We are trying to explain and understand that when you are running on this, using this kind of models to optimize the models, what are you trying to do? You're trying to use the right one. If you use the convolutional neural network for what we just did, there will be an issue. It will not be able to combine in this way because talking about what the different networks are designed for. The convolutional neural network is designed to capture images, mostly. That brings us to the next one. So you go to the next site and try to work with that site. But what I want to tell you is you have this, when you get back in your own private study, there's something I want you people to do. Try and distort these images. Play around with it. Try and distort the images and then combine them and see what you will get eventually. It's something to practice with. Okay? All right. So let's go to the next site. Follow the next link, this link. The ones that you post Snapchat. For those online, is IMAGER and so forth and so forth. IMAGER.
This one. I said drop an image.
Drop an image. Pick any image from your system, from your phone. Pick any image and drop it there.
I can click my picture.
Yes. And then let it now, let the AI tell you what that image is. The network that was used for this is the convolutional neural network. That was what was applied to design this. Pick any image from your system, from your pictures, from whatever you store, and then drop it there. Those of us at home, are we doing the same thing too? Pick any image from your system or around you, a picture, just drop it there on the site. What did it say? Gave you analysis. The prediction, is it what you expected? What did you do?
Just like
Okay, the motivational post. I see what it's telling you. It's telling you that could be an advertisement, it could be a poster, it could be a book publication, 97%. You see the analysis is giving you. The prediction, is it close to what we thought? And you're okay with that. Why don't you pick another image and drop out? Okay, please play around with it. What is it telling you? You put a funny photo.
No, I just describing everything about.
Yes, it fits. You see, it works with the different pixels and it's picking each and every one of them and giving you the analysis from it. Are you getting the same results? Are you satisfied with what you got? Okay. What about you? Okay, put another one. Put more images and see.
It brings out more results.
More results. Now we are looking at the predictions. Are the predictions close to what the image is?
These are adverts. So it's the prediction adverts 100%.
About 100%. Good. So you got it right.
Yeah, poster 100%.
That is how powerful your convolutional neural network is. That's what I'm trying to explain. Do we get the gist here? Those of us at home, are we getting it? Please let me see what their responses are. Mr. Ode, are they responding? Let me know whether I'm communicating with those at home or online. So you can do more with these tools. And then what we are trying to explain here is that for the different neural network architectures, they are used for different purposes. Okay? You tamper with these things. And then another one that is the most popular, which you can actually play with. No, for Chat GPT, which neural network captures text? Which is actually natural language processing.
Yes.
Somebody said it. Recurrent. Please, I know some of you were not in the last online class. Let's go back to it, okay? And look at the individual networks and look at their application areas and what they are designed for, what they work best with, okay? And then play around with this, what we have said. Something's going on here. Today is wonderful, right?
Yes.
Today is just fantastic. But don't worry. Just like I said, the organizers will make the slides available. Any slides, I'm sorry about that. They will make all the slides available. We had a little bit of hiccup because of the holidays, right? But some of you were able to join online and we are good. Play around with this. And then finally, there is a very popular one that I want you to go to practice with before we call it a day today. It's called Quick Draw. How many of you have used Quick Draw on Google? Quick Draw with google.com. It's there, you snapped it. It's at the last one. It's the last slide. Yes, the last link, sorry. Use Quick Draw. Quick Draw is a Google tool. It helps to make you understand how AI learn. And it helps to recognize images, which you yourself will draw. Then there's a platform, you can try it when you have your free time. You draw on it, and then it compares this with what other people have drawn and tries to predict what you have drawn. It will tell you to draw maybe like a shoe, or a football and all that. And whatever you did will be stored to train the AI. So the AI has this large database that it uses to predict and then tries to make the prediction better. Eventually, from all this that we have done, we are trying to make our model to operate at an optimal point. And that's the whole essence of learning models. Are we okay? That's the end. Any questions, please? Sorry?
People are
Still trying to access.
trees that are still trying to access the data.
That's the only reason why I relocated to physical.
The physical is better, but online, there's a reason why some people have to be online. But so far, did you follow on site?
Yeah.
For online, I don't know how. Yes, that's it. That's why I was trying to make sure they see everything. Okay, I don't know. Online, can you hear me?
Some of them are really. Exactly. Because this one is saying that it really imagine the picture and the content like ancient background.
Yes, some of them are following, but I think a lot of them will not be able to follow. Yes, yes, I know majority might not be able to follow, but that's fine. That's fine. So far, that's what we've done so far. You are going to get the slides, so don't worry. Everybody online, when you get the slides, try and follow the link and play around with the different AIs. And if you have more questions about what we've done so far, you can always text the questions to me and I'll do my best to be able to answer them. Are we okay? All right. So in the house here, no questions? Are you okay so far? All right. Thank you very much. Okay, you've shared it. Thank you so much. Thank you.
Question. So this last drawing, I don't understand it. So I'm trying to
No, it will tell you what to draw. And then draw something.
You can draw me.
No, it will.
She said draw a moon.
Draw a moon.
It's not telling me any other thing.
I see here, circle, potato.
Do you know why it's telling you all that? Because it's similar to what looks like what you have drawn. So it's telling you that it looks like this. There are predictions. It's trying to predict. So it's telling you it looks like this, it looks like that, it looks like that. But in actual fact, at the end of the day, when you click, when you submit, it's going to tell you whether you got it. Your drawing is okay or not. Yes, there's a countdown there. Did you see the countdown? It's going to tell you whether you got it right or not.
You are training the model, not.
You are actually training it, and it's picking all those, it's collecting all those data and giving you predictions. Thank you very much. I hope this class was okay so far. I don't think we like higher.
It's not the best.
But some kind of
These are like that.
serious hitches.
So the next module, are you the one taking us on? This one is
The next module, no, we'll check the timetable and see who falls into the next. Then we'll know.
Happy New Year, man.
Happy New Year. How are you?
So I sent to his an email.
Yes. Yes, I saw all of them before the system is, see what the system is just going bonkers. Assessment, I'm going to be posting the assessment questions. And so you go through, it's going to be multiple choice and answer them and submit and get that.
The attendance. Any attendance?
It's check for the yes, attendance.
Any attendance?
But this one is more.
Because everyone was really.
Because why is it easy for me? Because of having a little idea. So what is often to do something so physical, yes, that's why that's really doing that. Yeah, do where I can. You can around. Oh, so I get some questions that like because